Picture this. You're completely trapped in the examination hall. The clock is ticking down, and you're staring down the absolute final boss of the IGCSE Physics 0625 paper, forces. One wrong move, one forgotten formula, and your A star literally slips right through your fingers. But hey, we're not going to let that happen. Welcome to the Memory Palace. Today, we're treating this entire syllabus like a video game boss fight, and we're going to map out the exact attack patterns of the examiners so you can beat them at their own game.
Right, let's get straight into it. Think about a standard calculation for finding density. Say the mass is 50 grams and the volume is 20 cubic centimeters. 50 divided by 20 is exactly 2.5, right? The math is completely flawless. So why on earth did this student just lose the final mark on the paper? Well, it's because of the silent killer of physics grades, the missing unit. Without explicitly writing grams per cubic centimeter, that 2.5 means absolutely nothing to the examiner. It's just a random number floating around in space.
And honestly, this brilliantly illustrates why ordinary textbook revision completely fails you in the actual exam. You can memorize every single paragraph in your study guide, but if you aren't paying close attention to the exact mark scheme thinking, you are actively bleeding marks. Missing a unit here, giving a kind of vague description there, or skipping a crucial method step can easily cost you 3 marks on just a single question. And to put that into perspective, in the Cambridge system, 3 marks is literally the difference between an A and a B on a grade boundary. We have to start thinking exactly like the people grading your paper. So to defeat these topics, you need the ultimate weapon. I like to call it the top band answer framework, and it's built on 4 non-negotiable steps. Step 1, state the core concept. Step 2, pull the concrete evidence or data directly from the question prompt. Step 3, connect those 2 things using your scientific reasoning. And step 4, this is the real kicker, lock the answer in using precise examiner wording. Whenever you're facing a written response, this framework is your shield and your sword.
Okay, let's dive into this and face our very first boss: mass, weight, and density.
Now, this trio really forms the entire foundation of the forces topic, and honestly, it's exactly where most students get way too overconfident and get caught out by trick questions. First things first, we have to equip our exact terminology. Density, which is represented by the Greek letter rho, is officially defined as mass per unit volume. Meanwhile, weight is absolutely not the same thing as mass. Mass is the amount of matter, sure, but weight is the gravitational force acting on that mass, which we calculate as W equals mg. We absolutely must know exactly what variables we're manipulating before we step onto the battlefield, because confusing mass and weight is a guaranteed 0 on explanation questions. No exceptions. Take a really close look at a standard data table setup for a practical investigation. You are trying to measure the density of an irregular object using the displacement method. You've got mass in grams, initial water volume in cubic centimeters, final water volume in cubic centimeters, and then object volume. Pause for a second. Think about it. Can you spot the anomaly here? Notice how the column header for object volume has the unit completely missing. In a Cambridge practical investigation, designing a table without that final unit bracket will immediately cost you a core method mark right out of the gate. In a moment, I'll show you the examiner clue that changes the answer completely, the one subtle detail in the wording that shifts a question from a simple calculation into a massive trap. But first, you need the framework that makes that clue completely obvious. And this next comparison brilliantly illustrates the real difference between just knowing the physics and actually passing the exam. Think about a student writing, "It is heavy, so it sinks." Look, we all know what they mean, but that is a totally flawed 0-mark answer. It relies way too heavily on everyday language. Now consider this alternative. Object density is greater than fluid density, so downward weight exceeds upward buoyant force. Boom! That is our 4-step framework perfectly executed. We've got the concept of density, the reasoning of opposing forces, and the precise examiner wording of downward weight and buoyant force. That right there is an unshakable full-mark answer.
Right, let's move along and see how this builds as the difficulty spikes with our second boss fight: pressure and resultant force.
The examiners absolutely love using these concepts to test your multi-step mathematical logic, not to mention your ability to convert units when you're stressed. So here's a quick interactive challenge for you. We need to calculate pressure. The standard formula is pressure equals force over area. We are given a force of 200 newtons and an area of 50 square centimeters. Stop right there. Spot the critical calculation error before it even happens. If you just punch 200 divided by 50 into your calculator and excitedly write down 4, you've already fallen into the trap. Why? Because the standard unit for pressure is pascals, which absolutely requires the area to be in square meters, not square centimeters. Now, what's really interesting about this exact scenario is a specific number, 10,000. That right there is the absolutely crucial conversion factor from square centimeters to square meters. Because there are 100 centimeters in a meter, to convert the area, you have to square that 100. So you actually must divide your 50 square centimeters by 10,000. Under intense exam timing pressure, this simple number completely evaporates from students' minds, completely ruining their final calculation and costing them heavy, heavy method marks.
Let me just put on my examiner hat for a second so you can see how we think. We don't just deduct points for bad math, we actively look for specific common penalties. Rounding too early in your multi-step pressure calculations, that creates a compounding error that entirely shifts your final significant figures. We also take points off for vague explanations, swapping mass for weight, messing up your graph axes and data analysis, or suggesting really weak practical improvements. If you just write "be more careful" instead of "view the measuring cylinder at eye level to avoid parallax error," you are getting penalized. No doubt about it. So the absolutely crucial takeaway here is replacing those weak, everyday descriptions with bulletproof, exam-safe wording. Think about a resultant force question. One student writes, "The forces are unbalanced, so it moves." It's vague, it's unstructured, and it lacks real physics terminology. Now imagine another student writes, "A non-zero resultant force causes acceleration in the direction of the force." Now this is magnificent. It explicitly uses the phrase non-zero resultant force. It specifies acceleration instead of just saying it moves, and it links directly to Newton's second law, F equals ma. It's totally bulletproof. Before this particular boss fight ends, you need to permanently memorize this practical checklist to guarantee you secure every single method mark available. Number 1, do a final answer check to ensure you actually answered the specific question they asked. Number 2, verify your units are present and mathematically converted. Number 3, check your significant figures. Usually you're keeping to 2 or 3 for Cambridge. And number 4, this is my favorite, assess reasonableness. If you calculate the mass of a small wooden block to be 4,000 kilograms, you've definitely misplaced a decimal. Always pause and ask, does this number actually make sense in the real world? By following these steps, you now have the exact physics knowledge to conquer mass, density, pressure, and forces. But here's the ultimate twist. What if you know all the physics perfectly, but the question's command word is evaluate instead of describe? You see, the final door in our memory palace remains completely locked. Because if you don't know exactly how Cambridge command words instantly dictate the entire mark scheme, all of this phenomenal physics knowledge won't save your final grade. You simply cannot walk into that exam hall without the key to that final door. You absolutely need the top band evaluation framework to decode those specific command words. So subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Go watch our next explainer right now to unlock the exact command word strategies that decide your final mark band. The next boss is waiting for you there. Honestly, ask yourself, are you really prepared to lose a whole grade just because you misunderstood one single command word? See you in the next one.